Hello everyone, our group name is SZ, and the problem is a classification problem. First we load the data, and then see the description and information of data. And there are three attributes, which type are int, and others are object. The first do the data pre-processing, and first deal with NA, and first since only a few values of conditions are NA, and three datasets all have NA in condition attribute, so fill these missing values with none. And then do the feature selection. First we see the distribution of ratings, and from the figure we can see that the number of 5 are the most, and then see the drug name attribute. There are about 1,000 different drug names, and based on the figure, it can be seen that drug name has no obvious relationship with rating, so drug name is not used as one of the features. And then we see the condition, and as the same as the drug name, the condition is not used as one of the features modeled later, too, or either. And then we see the useful count. First, draw the scatter plot to see the useful count versus rating, and then for every rating we calculate the average useful count and plot. And from the figure, we could see that the higher rating with the higher average useful count. And then we see the side effects. Since there are only 5 cans of side effects, so we use label encoder to encode this attribute. And then we deal with review comments. Since review comments are contained with sentences, so we use TF-IDF methods to transform them into matrices, and then we transfer the rating to binary rating. If the rating is greater than 3, then it's 1, or other is else is 0. So we want to find a relationship between the binary TF-IDF matrices and the binary rating. We use random forest to find the relationship, and use a prediction of the binary rating as the encoder of the review comments. We named the new attribute PBR, predicted binary rating. So after feature selection, we select useful count, side effects, and PBR, these 3 attributes to build our models. First we do normalization, and then we use 3 models. The first is the random forest model. For the random forest classifier model, I set 4 parameters. The number of classification trees, the minimum number of samples, the minimum number of leaf, and the minimum impurity. The random forest is actually it's actually a strategy of strong learner by training several individual learners, and uses and the core method of random forest is the bagging. Suppose the training data has m samples, and use bootstrap method to resample from the samples with replacement, and finally forms t new samples with sample size m. that's that's the samples randomly sampling, and at the same time, the features are also random sampling. So the features are also sampled, which every new sample uses a subset of features rather than the whole features. So that's the core method of the random forest, and then and then define the main function and the fit function and the predict function, and that form the random forest classifier. So in the main process, we just from RF import random forest classifier. That's our classifier that we built.
The second model we choose KNN, and firstly I should define a class to implement the KNN algorithm model. And then I need define the training function. The training function saves all training samples. And then I need to define the predict function and predict each X predict. And in the predict function, firstly I should calculate Euclidean distance and find the smallest k index. And then I should count the label of k index and store them into top ky. And then I instance a dictionary D, and I should take the label y as the key and the category of label as a value. And I should write the count label and the number of labels into D. And then I return an array is the list of tuples of D. And I sorted the list by value from largest to smallest. And lastly, I return the largest value in D list after sorting. And we can see the performance evaluation. From the result, we can see the random forest classifier has much lower value in micro than in micro, which means that the prediction result is worse in some kinds of label. After checking the prediction value, we found the number of 1 and 5 are much more than 2, 3, 4, so that the micro F1 is much lower. And for KNN, we can see KNN classifier also has much lower value in micro than the micro. However, the F1 score in KNN is higher than that in random forest. So actually, lastly, we choose KNN as our final classifier. And we find the key attribute in this problem is review comment, which is hard to deal with it. The method we use is TF-IDF method to transform the review into matrix. There are some other methods to deal with it, such as a word embedding. The micro F1 score is about 0.55, which is not a good result in classification. However, the problem is an NLP. It's not easy to deal with NLP using machine learning algorithm. To get a better score, we should try convolutionary neural networks such as CNN, LSTM, which needs more resources like better hardware and enough training time and storage.